Hey friends, the bad news is you're not in class. The good news is you know where to go for help. So I hope you're doing okay. And we are looking at chapter 2. Can I show it another way? Welcome to Monday, October 23rd. So what we're going to do first is we're going to come in and do a fast bridge warm-up. Okay, and then from there we're going to look at some classwork. Some of the problems we were introducing last week. We're going to do some think, pair, share. And we're going to work through those kind of together. We're going to go on your own, work with your group, and then share ideas on the big wheel. Learning target today, we will develop an understanding of multiplication as repeated addition, and then our success criteria. Can you change a repeated addition problem into a multiplication problem? So some of the questions that we're looking at in 68 and 75, we looked at before. Remember this one? Cecil needs to move 6 feet, but you only have lengths of 5 and 8. 2 solutions to move 6 feet with only 5s and 8s, and we did that. Cecil moved across the tightrope, showed 2 ways to represent the move with number expressions. Did it get to the same endpoint? Cecil is now so good at crossing the tightrope, he can make leaps of 7 feet at a time. He crossed these ropes, he crossed the rope in these leaps as shown. Record his move in 2 ways. What is easier to record? When adding the same number several times, multiplication can help. See where we're going here, friends? It might be easier, instead of writing 3 feet plus 3 feet plus 3 feet plus 3 feet, it might be easier to write 4 times 3 feet instead of 3 plus 3 plus 3. How would you write 2 plus 2 plus 2 plus 2 plus 2? How did Cecil, the tightrope walker, move if he started at point A and his moves were recorded as the expression 3 times 6.2 plus 2? Draw a diagram. Record how far along the rope he was when he finished. Then, 272, imagine that Cecil, the tightrope walker, starts at point B. Where are you, point B? Are you there? There's point B right there. Good. Imagine he starts at point B and walks towards point A, as shown here. How could you write this? Is there more than one way to write this? Of course there is, because we were just talking about that. Where does he end up? To represent, Chad drew this diagram at the right. To represent 2 groups of 3. How would you draw 5 groups of -3? I think you can do that. And then what the 2 equal expressions, 2 groups of 3, and 6 can be represented with the diagram at the right. Draw similar diagrams for each of these expressions. What does 2 groups of 3 plus 5 mean? What does 2 groups of 3 plus 5 mean? Are 2 groups of 3 plus 5 the same as 2 groups of 3 plus 5? Explain, draw a diagram. And then finally, can you draw this one? 3 groups of -2.5 plus -4. And is that the same as 3 groups of -2.5 plus -4? All right, so that's what we're going to do. Thinking, sharing in a group, and then sharing in a big group. Then we're going to homework. We're going to go to 279, 280, 281, 282, 283, and 284. We're doing this with the cups. So if your group's working on 279, you're blue, 280, you're green, 281, pink, 282, orange, 283, red. And then if you're done with 284, then you're going to white. Okay. Let me just show you those really quick. 279 through 284. Find the value of these. And they have some absolute value in there too, if you remember what that means. And if you don't remember what absolute value means, get on your homework help. 280, we're talking about distributive property. Homework help. We have some diamond problems. We have some fraction, decimal, percent problems. We have this problem. Camille had a fun birthday party. Of course she did, Camille, with lots of friends and family attending. The party lasted for 3 hours. She and her friends played games for 3/8 of the time, ate pizza and cake for 50% of the time, and spent the remaining of the time opening presents. Draw a diagram and make calculations to show the amount of time spent opening presents. Homework help if you need it. And then 84. Jonna measured the heights of the sunflowers growing in her backyard. Here are the heights that she found in inches. Look at all these. That's all your data. And then find the mean and the median of the heights. Okay, and create a histogram to represent this data. And your histogram should have 4 bins, each with a width of 15. Need some help on that? Homework help. And this one's kind of cool too, because you can click on an e-tool and you can use the e-tool to help you organize your data. After that, we're going to go, if we get that far, and we might not, this might be it for the day, but we're going to introduce 2.2.5, and it's how big is part of a part. So what we're going to do, I'm going to read this to you and then show you what we're going to do. So let's go 2.2.5. And it says, Cecil has just created a spectacular routine. A routine is a sequence of moves to get from start to finish. His routine has 2 parts. The first part consists of a series of creative leaps followed by a somersault. The first part ends with Cecil doing an elaborate bow while balancing on one toe, and then he moves into the second part of the routine, which includes several back flips and spins. And when perfectly performed, the routine moves Cecil exactly to the other end of the tightrope. The routine can be represented by the following equations. First, 3 groups of 2 plus 3 groups of 3 plus a -5 plus 4. And then he pauses, takes a bow, and then part 2, he does 5 and then 3, and then 4 groups of 1 plus -1, and then -3, and then -5, and then 3 groups of +5 plus -2, and then +1. So work with your group to draw an accurate diagram to represent Cecil's routine, and then answer the following questions. I think we might stop there. So we're going to look at an accurate diagram, and then we're going to actually model it, because I want to see what that looks like. Right? So we're going to practice groups moving according to this rule. And then I think what we'll do, if we have time, is we'll get all the groups together and we'll model this and see if they can execute all of these steps. And then the other groups can evaluate in their groups, was that group able to pull off part 1 and part 2? Did it look like it was supposed to look like? Okay? And that's what Monday's going to look like. If we get done early, I think we're probably going to finish somewhere in here. We will model it, and if we get through that, we're going to do 286 to 289 in classwork, and then our closure question is 276. How far did they move? Hey friends, so that is Monday, October 23rd. I hope you're well. I hope we see you. We always miss you when you're not here. And I hope you have a beautiful Monday. All right, see you later.